Some objective bits related to this topic. Here, first one, the Van Hoff's factor accounts for extent of solubility of solute, extent of mobility of solute, extent of dissolution of solute, and extent of dissociation of solute. So generally, Van Hoff factor that is applicable for dissociation and association reactions. Dissociation of the solute and association of the solute. So this is the correct option. Okay. Next, if alpha is degree of dissociation of sodium sulfate, the Van Hoff factor used to calculate molecular mass is. So here, sodium sulfate, Na2SO4. On dissociation, it forms 2 Na plus ions and 1 SO4 2 minus ion. Okay. So, one particle of Na2SO4 on dissociation, it forms the sodium ions and sulfate ions. Okay. So, initially 0 ions are there. Okay. After dissociation, we get 2 alpha and alpha ions of sodium and sulfate ions. And particles left is 1 minus alpha. Then I factor for this. I is number of particles after dissociation by number of particles before dissociation. So, number of particles after dissociation 1 minus alpha plus 2 alpha plus alpha by 1. Okay, minus alpha plus alpha. So, 1 plus 2 alpha. So, 1 plus 2 alpha, option C is correct. Okay. Next, which of the following salts will have same value of Van Hoff factor as that of potassium ferrocyanide K4FeCN taken 6. Okay. So here different options are given: aluminium sulfate, sodium chloride, aluminium nitrate and sodium sulfate. Okay. So come to potassium ferrocyanide K4FeCN taken 6. After ionization, it forms 4 potassium ions and 1 coordination complex ion. Okay. So, total number of ions produced is 4 potassium ions and 1 coordination complex. So, 4 plus 1, total number of ions are 5 ions. Okay. So, here aluminium sulfate. Aluminium sulfate on dissociation forms 2 aluminium ions and 3 sulfate ions. Okay. So, 2 aluminium ions, Al2, 2 aluminium ions and 3 sulfate ions. So, total number of ions here is Al2SO4 taken thrice. Total number of ions are 5. For NaCl, Na plus Cl minus 1. And for aluminium nitrate, here 1 plus 3. So, 4. And for Na2SO4, 2 plus 1, 3. 2 Na plus ions and 1 SO4 2 minus ion and Na plus and Cl minus. So, total number of ions here is 2. Aluminum sulfate is 5. Aluminum nitrate is 4 and sodium sulfate is 3. So, which one? First option. Okay. So, Al2SO4 taken thrice. Next. Van Hoff factor for 0.1 m barium nitrate solution is 2.74. The degree of dissociation is. We have to substitute I factor value in formula directly. For dissociation, degree of dissociation alpha. So that is equal to I minus 1 by N minus 1. Okay. So here N indicates the number of ions. Okay. Number of ions present in that substance. So what is I value here? 2.74. Okay. And number of ions, barium nitrate. Barium nitrate having 3 ions. 1 Ba2 plus ion and 2 nitrate ions, NO3 minus ions. So total number of ions are 3. Okay. So I is equal to 2.74. N is equal to 3. So alpha is equal to 2.74 minus 1 by 3 minus 1. So 1.74 by 2. Okay. So 1.74 by 2 So its value is 0.87. But here degree of dissociation, that is given in percentage. So into 100, 0.87 into 100. So that is equal to 87%. Okay. Next, Van Dyck's factor for 0.01 m aqueous solution of acetic acid is 1.04 and the pH of the solution is. Okay. So this is some different question mark. Here you have to calculate pH value and Van Dyck factor is given in the data. Okay. So pH formula is minus log H plus. Okay. So pH is equal to minus log H plus. Okay. So to calculate H plus ion in dissociation reactions by using degree of dissociation, we use formula H plus is equal to C alpha. C alpha. H plus is equal to C alpha. What is C? Concentration. Okay. So concentration is 0.01 m. And alpha is degree of dissociation. Here I factor is given. From I value we can calculate the degree of dissociation. Okay. So alpha is equal to I minus 1 by n minus 1. Okay. So what is I here? 1.07. So 1.04 minus 1 by n. N is number of ions. Acetic acid CS3COOH. It on dissociation gives acetate ions and H plus ions. So 2 minus 1. So 0.04. Okay. It is equal to 0.04. And what is the concentration? Concentration is 0.01. Okay. Then H plus is equal to C. What is C? 0.01 into 0.04. So we get 0.0004. Okay. So 4 into 10 to the power minus 4. That is H plus ion concentration. Okay. From this we can calculate pH. So pH is equal to minus log 4 into 10 to the power of minus 4. Okay. Log 10 to the power of minus 4 is minus 4. Here minus sign is there. So 4. Okay. This is equal to 4 minus log 4. Log 4 value 0.6020. So 4 minus 0.6020. Okay. So this is equal to 3.3980, which is equal to 3.4. Okay. So this is the correct option.